Hi everyone, let's take a look at the 19th problem from Blind75 LeetCode today, which is unique path. What is the problem about? So we have a robot. This is a cute robot at the start position, which is 0 0. This is at a m by n grid. The robot is initially located at the top left corner, which is 0 0. The robot tries to move to the bottom right corner. So it has to move to the bottom right corner, which is the star here, and which is grid of m minus 1 n minus 1. The robot can only move either down or right at any point. So it can only move either downwards or the right side at any point in time. Given two integers m by n, return the number of possible unique paths that robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 2 into 10 to the power 9. Okay, so we are given a grid and the robot is at the start position, which is 0 0. Okay, and we need to find how many unique paths are there to reach the finishing line, which is grid of m minus 1 n minus 1. So the constraint is the m can be m is 1 less than or equal to m and n less than or equal to 100. So the value could be somewhere from 1 to 100, the rows and columns. Let's see how we can solve this. So here I have I just drew a 4 by 3. So m is this is 5, right? Yeah, 5 by 3. So m is equal to 5, n is equal to 3 here, grid, and say the robot is here. So it can move to right or downwards, and it should reach here. This is the start end point, and we need to find out how many unique paths are here. Okay, so let's see. So we have to, something we need to note here is, for the first row, the robot can only move in one direction. So the number of unique paths to reach any of the first row elements is going to be 1. On the column as well, since it can only move to the right and the down, so there is no way we can go and come back, right? So the number of ways it can move downwards is also 1. Suppose we have to come here, and what is the number of unique paths to reach this particular location? This is going to be equal to how many unique paths to reach here plus how many unique paths to reach here, right? So from this, what we can understand is that, say, number of unique paths to reach, say, m comma n is equal to number of unique path to reach m minus 1 comma n plus m comma n minus 1. So that is the unique path to reach here plus unique path to reach here. So we got the formula, right? So only edge case is whether if it is first row or first column, this robot can only move in, there is only one unique way. So we need to use that base case here. Let's see how we can implement, and then we'll see how we can improve this, right? So if m is equal to 1 or n is equal to 1, that means there is only one way, right? Otherwise, return self dot unique paths of m minus 1 n plus self dot unique paths of m comma n minus 1. Okay, so this is one solution. What is the problem with this particular solution? So we will be calculating this value the same value multiple times, right? So how can we solve this? We can use dynamic programming to use to yeah, instead of doing this recursive method, we could use dynamic programming. This is similar. Let's see how we can use dp to solve this. So initially I'm going to define dp, where I am going to say this is, there is only one solution for the first value for I in range of m. So we write a 2D array where the number of ways to unique paths to reach a particular grid, particular what do you say, column in that matrix and the grid is 1 initially. So we are setting it, then we are going to iterate it for column in range of, we start with 1 not 0, because for 0 it is going to be 1, as we saw in the last solution. For row in range of 1 comma n, so we start from the next row. dp of column and row is going to be, what is it going to be? dp of column minus 1 row plus dp of column row minus 1. It's the same equation. So once that is done, we will have the result in m minus 1 and n minus 1 the location. So let's see. Yeah, let's try submitting it. Yeah, passed. So what is the complexity here? The complexity is order of n square here, because we are doing it oh, I don't want to say n square, order of n by m, where m is the number of columns and n is number of rows. So yeah, so that is it. What is the space complexity? Space complexity is the space used for dp, which is again m by n, so order of n by n. Okay. There is actually a different way to solve this, just using max. So ideally, if you look at it, we can kind of find that this is a classic combinatorial problem where if you remember, if you think about it, there are h plus b moves to do from start to finish, where h is the m minus 1 move, right, horizontal move, and b is n minus 1 vertical moves. One could use whether to move to the right or the left. So there are two ways we can do, right? So so what we are asked is to compute how many ways one could choose say p elements from p plus k, where p is the sum of so this is p and this is k, something like that. Okay, so what we know in mathematics, this is kind of called as binomial coefficient. The number of horizontal moves to do is m minus 1, number of vertical move is n minus 1. So the result is going to be m minus 1 plus n minus 1 factorial divided by m minus 1 factorial into n minus 1 factor. This is the simplest solution. So let's try coding this, right? So we could just simplify this further using mathematical problem. So we can think that we are given, say, m here m plus n. If you sum this up, m plus n minus 2 columns, and we need to choose all the combinations or the unique paths in that. So that is kind of p plus q factorial way. So let's compute this. Okay, so we need to find the factorials, right? So let's import that from math, import factorial. and so what we know is we have to factorial of m plus n minus 2 divided by factorial of m minus 1 into so we can do into factorial of n minus 1. Okay, so let's try running this. Let's submit it. Yep, so this beats 95%. So this is just a mathematical equation to find how many unique paths are there to unique paths are there to select a particular particular set of elements. So yeah, so that's it. So that's the end of this solution. I hope you liked it, and if you didn't understand this or if you need any further explanation, please let me know in the comments. Please don't forget to like, comment, share and subscribe to the channel, and I would really appreciate if you could click on the bell icon so that you can get notified when I upload a new video. And thank you so much for watching. Let's meet with another solution pretty soon, and until then, see you. Bye bye.